Quarter 4, week 1, day 4, find the quotient. We love these. So we have 2 over 9. The division sign becomes a multiplication sign, and we flip the 4 over 15 and make it 15 over 4. All right. I like to do some cross-reducing if possible. Can we do any cross-reducing? Yeah, I can look and see that the 2 and the 4 both have a 2 can go into it. So 2 goes into 2 once. 2 goes into 4 twice. So that's replacing those. And I also noticed that we can divide 3 into both 9 and 15. 3 goes into 9 3 times. 3 goes into 15 5 times. All right, so now our math's going to be pretty easy. 1 times 5 is 5. 3 times 2 is 6. And the answer is 5/6. Okay, did we have to do all the cross-reducing first? Nope, we could have just multiplied across and then had 30 over 27, and then we would have had to have simplified it from there. So you can do it either way, but the answer to this is 5/6. Joe has read 140 pages of his 300-page book. What percent of the book has he read? All right, so we just put 140 because that's the amount that he's read so far. And then 300 is the total. That always goes in the denominator. So to find the percent, all you have to do is take 140 divided by 300. Okay, and that equals 0.46 and then repeat it on forever. Okay, so basically what it comes down to is what was the percent? We could actually just say, since it's 4.6 repeated, you can just say 46.7%. That'd be a possibility. Or you can just say round it to 47%. Okay, or 46.6 and then 7%. Okay, any of those would be good answers. Okay, so 140, so he's 47-ish% of the way through the book. Write an equivalent expression for 24x plus 16. So I actually found all of the factors that both go into 24 and 16. What we see in common is they both have a 2, they both have a 4, they both have an 8. So typically you take the greatest one and you use that one. So let's put 8 outside the parentheses. 8 times what is 24? 8 times 3, so it's going to be 3x plus. 8 times what is 16? 8 times 2. So there we go. There's an equivalent expression. We could have also done 4 outside, right? It didn't say we had to use 8. And then 4 times 6 is 24. And then 4 times 4 is 16. So that would have been another one. Okay, or we could have used 2, right? 2 times 12, which would be 12x. And then 2 times 8 is 16. So that's another one. So we actually made 3 different equivalent expressions for 24x plus 16. Like I said, usually you use the largest number that goes into both, but it doesn't say that you had to. So there's our answer. Write the inequality this number line represents. Okay, so what number has the dot above it on the line? Well, that would be the 6, right? And then we can actually put any number we want to. I usually just put an X there. Now, what do we notice about the circle on the number line? Is it colored in or is it not colored in? It is colored in, right? So we're going to have the equal sign on that because whatever the answer is, it can equal 6. Okay, it doesn't have to be bigger than 6 or less than 6. It can actually equal 6. All right, and then we just look at it, and so this is colored in here, and then we go the direction that the arrow is graphed. Okay, are those numbers bigger than 6 or are they smaller than 6? Well, then the answer is bigger than. So x is greater than 6 or equal to 6. There we go. X is greater than or equal to 6. There are 2 squares. One has a side length of 12 inches and the other has a side length of 14 inches. What is the total area of both squares? All right, so The one on the left we have, well, and again, they're squares. So you know that every single side is the same length. So if we know that one side's 12, then all the other sides are 12. So it's going to be 12 times 12 is going to give us the area of that square. And then again, it's a square, so every side's going to be the same. So it's going to be 14 times 14, and that's going to give us 196. Okay, so if we want to know the total area of both squares, we're going to take 196 plus 144, and that's going to be equal to 340. So we add these two together, and our total area is 340. And what are we measuring in? Inches. 340 inches, and since we're in area, it's in squared. 340 inches squared is our answer. A rectangular chair cushion measures 14 inches long, 12 inches wide, and 3 inches high. All right, how many square inches of fabric could you need to cover the cushion? So we're not finding the volume, we're finding the surface area. All right, so we need to find a top and a bottom, a side, and a front and back of this cushion. Okay, so let's just do that. The top and bottom is going to be 14 by 12. Okay, so if we do 14 times 12, that equals 168. I'm going to write that down twice. Why am I writing it twice? Because that is both the top and the bottom. All right, let's do the sides. Well, the sides are going to be 3 by 14, right? So it's going to be 3 times 14 is 42, and I'm going to write that down twice because that's one side and the other side. Now we need the front and the back. The front and the back is 12 by 3. 12 times 3 is 36, and I'm going to write that down twice. So do we have the area of all of the sides? Top, top, bottom, or side, side, bottom, bottom. Yep, that's all of them. Okay, so then we're just going to add all of that up. So we have 8 and 2 and 8 and 2. Those are 10 and 20 plus another 12. So that's 32. 32. And then we have 6 and 4 is 10. 6 and 4 is 10. So that's 20 plus 9 more is 29. And then we have 2, 3, 4 over here. So it looks like it's 492 inches squared. Okay, that's how much would be needed to cover the entire cushion. 492 inches squared. Andrea's math test scores were 76, 88, 82, 94, and 88. Find the mean. Okay, that means we're going to add them up. We're going to add all of them up and divide by however many numbers are in the data set. There's 1, 2, 3, 4, 5 numbers in the data set. So basically we're going to add 62 plus 82 plus, 76 plus 82 plus 88 plus 88 plus 94. Add all those up, divide by 5. So let's do that. We have 76 plus 82 plus 88 plus 88 plus 94. That's going to equal 428. Okay, so to get the mean, we're just going to take 428 and divide it by 5. Divide 5 into it. So 428 divided by 5 ends up being 85.6. All right, so that's all we have to do to find the mean. Remember, you're adding them all up and divide by however many numbers are in the data set. So to answer this one is 85.6 is the mean. Find the mean absolute deviation again. Okay, remember that's called the MAD, mean absolute deviation. You actually might see it abbreviated just like that. All right, and I always like to put the numbers from least to greatest, so I'm going to rewrite our data set. 2, 3, 4, 5, and 5. All right, 2, 3, 4, 5, and 5. All right, so you can probably already find the median. That would be the number in the middle there, right? Okay, the mode's easy to find because it has 2 5s, so that's easy to find. But they're not asking us to find the median, the mode, or anything like that, or the range, right? The range would be 5 minus 2, which would be 3. But we're finding the mean absolute deviation. All right, so first of all, we need to find the mean. How do we find the mean? Add up all the digits and divide by 1, 2, 3, 4, 5, because that's how many numbers are in the data set. So we have 2 plus 3 plus 4 plus 5 plus 5, and that equals 19. Okay, so all of this is 19. Okay, but we have to divide by 5. 19 divided by 5. So 19 divided by 5 is going to be 3.8. 3.8. So guess what? Our mean, let's find a different color. Our mean is 3.8. So do you remember what we have to do with that now? You have to take every number in the data set, which is a 5, and another 5, and a 4, and a 3, and a 2. And you're going to have to subtract 3.8 from each one of those. Okay, so, all right, so then we have negative or minus 3.8. So let's do 5 minus 3.8, and that equals 1.2. And then we don't have to do that again because we know it's exactly the same. 5 minus 3.8 is 1.2. Then we have 4 minus 3.8, and that's just going to be 0.2. And then we have 3 minus 3.8, and that's obviously just going to be 0.8, right? So it's a negative 0.8, but once again, we don't worry about whether it's positive or negative. We just want to know how far it is away. And then we have 2 minus 3.8, and that equals 1.8. All right, so here is the whole row of how far away from the mean each one of the numbers is. So let's find the average of those. Well, we have 8 and 8 is 16, 17, 18, 19, 20, 22. So we have 22 here. 2, 3, 4, 5. So and 5 on this side. So it's 5.2 when you add all these up. Then you have to divide by the number in the data set to get the mean absolute deviation. So we have 5.2 divided by 5. So 5.2 divided by 5 equals 1.04. So guys and girls, this is our mean absolute deviation. 1.04 is our MAD, our mean absolute deviation. Okay, so you have to find the mean first, then subtract every single one of the numbers from the mean. Okay, then find the difference for how far away from the mean is each number, and then take that divided by 5, which means that this is the mean, and typically a number can be 1.04 lower than 3.8 or 1.04 higher than 3.8, and that would be a very reasonable number to have in the data set. So there we go. All right, these are some quick ones. Graph the integer. Remember, the integer is any number, positive or negative. It actually includes 0. An integer is any number that's positive or negative that does not have a decimal or a fraction, right? So graph the integer 6 and its opposite. All right, well, I'm going to put a dot right there. I know I'm going to go through the 0 and go the same distance on the other side of the 0, and there's our opposite. All right, graph the integer 0 and its opposite. All right, so I'm going to graph 0, and to do the opposite of 0, the opposite distance, basically I would just flip that dot over like a coin, and it would be exactly in the same spot again. So that's it. So to graph 0 and its opposite, that's how you would do it. Once again, a lot of times people like to graph the opposite of the opposite. It's not on this, but if they did and they said, well, what's the opposite of 5? Well, obviously the opposite is -5, and then the opposite of that would be right back to here. So if you do ever see something like that, where it's saying graph the opposite of the opposite, okay, that's what it's meaning, all right? Okay, that's all it is for this day.